So welcome back, guys. Uh, we've been having a couple of troubles to stream the reading live, so just I'll pick up from where we stopped the last time. Okay, let me get the book. Okay, I think we've okay. So I think I've read up to this place. Follow this place. So we are talking about the shed. Let me get my pencil. We're talking about the shed. Talking about the shed. So if we think of this in terms of their software equivalent, they would range from using a pre-built off-the-shelf software package all the way through writing an entirely custom. So what they are trying to say is there are different ways to get a shed into your backyard. Whether it's a pre-built, you built it and they just deliver to you, when you order for sofas, then maybe it's a shed kit where each and every part, like you order from what's the name of this place? Is it Care or Ikea or something? So they send you a box of different parts of the chair, then you fix everything. But you can also have plans. You can also go as you making a decision about the kind of wood, how it's going to look like, the height, the width, the kind of nail you're going to use. Starting everything from the scratch. So that's also possible. If we think of this in terms of their software equivalent, and they would range from using a pre-built. So if you want to compare it to software development, they would range from using a pre-built off-the-shelf software package all the way through writing an entire custom system to solve your problem. So if in software engineering, you don't have to write all the code yourself. You can look for some libraries that might have, let's say you want to create a PDF now. It's not that you yourself will not be able to build it, but to build it from the scratch yourself, a PDF generator yourself, it's going to take time. However, there are some libraries, there are some people that have built packages for such functionalities. So although you'll be using what they have built, how they have defined it to be used, there will be some limitations, but those limitations you may not feel it based on your own requirements. Do you get it? So yeah, so it's just like you are buying a pre-built shed or a shed kit. You're not the one designing, you're not the one building it from the scratch. So, but we also had more flexibility. But you know, flexibility if you're using a package, the flexibility will be reduced. So, if you want that flexibility, in other words, the least difficult is the least flexibility because most of the decisions have been made for you. They have determined something. You get it. So, it is now able to compare. If it is pre-built, it is simple to start using, but there's no flexibility. You're using a previous software, you are talking about a software. So if you are assembling a kit, it is easy, but very little flexibility. Mhm. So that's that. If you are building from scratch, it is difficult, but you have the flexibility. You can determine my chair will have only three legs. Do you get it? Or my shed will only have three stands. Whatever. If it does whatever you want it to do, then it is fine. So in terms of software, you want to write the software. So you want to write the software entirely from the ground. Software engineers tend to choose the build from the scratch option most of the time. Yeah, exactly with something that people have not done before. You want it according to your own tastes. You want it according to your own taste. Software engineers tend to choose build from the scratch, but it's going to take time most of the time. Some Sometimes this is necessary, particularly in cases where the problem we are solving and maybe you get it. That's what I just said. Other times, this choice wins that in the cost benefits analysis ratio. 1 minute. Let me see if people want to join this. Mm, 1 minute. 1 minute. Let's see. Really. So the link is https on YouTube, youtube.com/watch query view, which is view. Then we have AGDSYSOX 9NW. So that's the link. That's the link. That's hopefully does not. So okay, let's continue. Sorry for that intermission. So it turns out that choosing one of in between is customizing existing software. So at this level, design patterns are built from prints. You build from what? From blueprints. It's not from the scratch, but something like this. You know, this one. Just like blueprint for a shed, come with dimensions. You see locations of the doors and windows. They design, they specify where it should be. You get it, that you want this, then it's been specified. They might not actually do that for you, but there's a plan out there to tell you, to guide you. That from, I think they would have done that from watching, making mistakes, learning from what people have been doing or what they have done in the past, to see that okay, when we did it like this was the result. It was good when we did like this. It was bad when we did it like this. So there's not that blueprint that okay, it's like a recipe. You get it? Just like blueprints for. I want to believe he is going to mention recipes. Uh, in software, this often means specifying high-level layouts of the code. You see, like a plan of a house or something. However, it is rare that a design pattern is made to be used entirely on its own. Yeah, you may deviate, but you pick the best of it. The entire systems. In other words, the blueprint focus on the shape of a single aspect, like the roof shape or component, rather than the entire shed. Okay, this might seem like a downside at first glance, but that's the only case if the goal is exactly to build a shed. You are trying to build something sort of like a shed, but not quite a shed. Then having blueprint for each area complements, you can mix a lot of things. Yeah, that makes sense. This carries over into our discussion of patterns. Since each one tends to focus on a single component or problem type of system, helping you build exactly what you want by assembling lots of pre-designed pieces. For example, if you want to add debug logging to your system, you will likely want one and only one way to log messages. There are a lot of ways you could do this. For example, using a shared global variable. Hmm? But here, but there happens to be a design patterns aimed at solving this software problem. So the design pattern for you to log. Especially it is debugging. This pattern describing the seminal work design patterns gamma eta and identify. It's called singleton pattern. So what are singleton pattern? And it ensures that only a single instance of a class is created. This blueprint calls for a class with a private constructor and a single static method called getInstance, which always returns a single instance of the class. It handles creating that single instance if and only if it does not exist yet. So that means that global variable is unique. This pattern is not at all complete. What good is it to have a singleton class that does nothing? However, it is well defined and well tested pattern to follow when you need to solve this small compartmentalized problem of always having a single instance class. So if you want a single instance of a class, then the pattern that you should follow is this guy, singleton pattern. Now that we know what software design patterns are generally, we have to ask the question, what are API design patterns? What are API design patterns? Using the definition of an API as described in chapter 1, an API design pattern is simply a software design pattern applied to an API. So we are not following it down. All APIs are what? Are softwares, right? Not all softwares are API. So if we are sure of what a software design pattern is, then applying it to API now. So we are going to the specifics of an API. Now that we want to talk about design patterns. This means that API design patterns, just like regular design patterns, simply they are blueprints for ways of designing and structuring APIs. Since the focus is on the interface rather than the implementation, in most cases, an API design pattern will focus on the interface. Let me take that again. This means that an API design pattern, just like the regular design pattern, are simply blueprints, yes, for ways of designing and structuring our APIs. Since the focus is on the interface itself, not inside, is that what you're saying? Rather than the implementation. In most cases, an API design pattern will focus on the interface exclusively. Oh, really? Without necessarily building out the implementation. While most API design pattern will often remain silent on the underlying implementation of those interfaces, sometimes they dictate certain aspects of the API. For example, so what they're trying to say, what the author is trying to say is, we have these are API box, the black box itself. So these are the interface. How you are able to relate with it. So what he's trying to say is some design patterns only talk about these guys, not what is implemented inside here. They get it. So that's what the guy is saying. That's what the guy is saying. So 1 minute. So that's it. Why most of API design will often remain silent on the implementation. For example, an API design pattern might specify is certain RPC can be eventually consistent, meaning that data returned from the RPC could be slightly stale. For example, it could be read from a cache rather than the authoritative storage. We will get into more formal explanation of how we plan to document API patterns. How we plan to document API patterns in the data section. So we need to document the patterns. But first, let's take a quick look at why we should care about API design patterns. So why API design patterns? Why are they important? So API design patterns are useful in building APIs, just like blueprints are when building a shed. They act as a pre-designed building blocks we can use in our project. What we didn't dig into is why we need these pre-designed patterns. Okay. So why do we need it? So we are not trying to assume here. Aren't we all smart enough to build good APIs? Don't we know our business and technical problems exist? Aren't we smart enough to build good APIs? Don't we know our business and technical problem best? We do. While this is often the case, it turns out that some of the techniques we use to build really well designed software don't work as well when building APIs. Okay, so why are APIs different? More specifically, the iterative approach advocated in particular by the agile development process. It's difficult to apply when designing APIs. The iterative approach is difficult to apply when designing APIs. So is it trying to say that agile development process is not so much good for designing API? Because that's what I just, more specifically, the iterative approach, advocated in particular by agile development process is difficult to apply. To see why, we have to look at two aspects of software system. First, we have to explore the flexibility or rigidity of the various interfaces generally. We have to explore how flexible, how rigid are they of the various interfaces generally. Then we must understand what effect the audience of the interface has on the ability to make those changes and iterate on the rest of it. Because basically, if you have told someone that when they want to fetch a user, I'm talking about the flexibility of the interface now, that let's say this is your base URL now, then let's say you say users, then you say ID. That means they can fetch a particular user with this, right? Then you now come out of your own something, you now come and say, users, you now use query ID is equal to, you see, although that's still going to do the same thing, the implementation might have changed a little bit, but moving from year to year is going to cause a lot of problem, especially for people that are consuming it, because the structure is totally different. So the interface has changed. The interface has changed. Okay, so let's move on. Let's see. So as we saw in chapter 1, APIs are special kinds of interface that are made primarily so computer systems can interact with one another. That means it is programmatic. It's not that somebody is coming to check and see. So it's like computer integrating to a computer. It's computer speaking to one another. So while having programmatic access to a system is very fragile, it's also much more fragile and prone to changes to the interface can easily cause failure, because if somebody's computer is talking to your computer through this line, but you have changed the line to this one, It's like somebody sending you and okay, let's say you and your friend, somebody is sending you a parcel from let's say you're expecting the parcel at Lagos Port. You're expecting the parcel at Lagos Port here. So then somebody is not sending it to which other port do we have? I don't even know. Somebody is not even sending it to it's not sending it to a post office in Ibadan. You see. That means you will be here waiting while your parcel is here. If the sender did not do anything, then you not know that you are meant to go to Ibadan to come pick it. That's it. So that flexibility is not that there, especially the interface. You don't just change your interface. Even when you version it, you say blah 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 blah. Let's say your versioning something is inside this base URL now. You say V1, then you say V2. The consumer still need to know that this thing has moved, or you version it as a V2. Yeah, that's the version it helps. It's a V2, and this V1 is still active. Don't just duplicate this guy and say you're using this one. So yeah, let's move on. As research on APIs are special kind of interfaces that are made primarily so computer systems. So it's so much fragile and brittle in that changes to the interface can easily cause failures for those using the interface. Yes, like I've explained. For example, changing the name of a field in an API, something like that too. Let's say instead of ID, okay, let's say same thing, because this one doesn't matter to you, sure. But this guy, if you're using this query and out of nowhere you change it to let's say ID, capital letter D. So this one also depends on the kind of platform that you're on. Some platforms are not case sensitive, some are case sensitive. Yeah, depending Apache, Node.js, all this kind of things. Okay. So from the perspective of the API server, the old code is asking for something using a name that no longer exists. This is a very different scenario, expecting something in Lagos, but something is not in Ibadan. But this is very difficult scenario for other kind of interfaces as graphical user interfaces, which are used primarily by humans. You get it? They are used by humans. But this one is computer to computer rather than computers, and as a result are much more resilient. Because if tomorrow, now I'm using Voxit reader now, if tomorrow Voxit should change anything here, maybe they change an icon, now it looks, maybe they change a label, as human I'm able to still adapt. I can this is not this was not how Voxit interface used to look like, maybe like 5-7 years ago. No, this wasn't. But I can still use it fine because I can interpret, I can adapt to the changes. But maybe it is a computer that needs to read the screen. A small change there is going to break things. That's what you call the breaking change. This means that even though a change might be frustrating or aesthetically displeasing, it typically won't cause catastrophic failure where we can no longer use the interface. For example, changing the color or location of a button, like I just explained now, but we can still figure out how to accomplish what we need to do. Basically, that's what I just said. We often refer to the aspect of an interface as its flexibility, saying the interface where user can easily accommodate changes are flexible, and those where even small changes cause more failure. This distinction is important because the ability to make lot of changes determine in large part. Okay, so if you can make more changes, then it's flexible. If you can't, it's not flexible. Okay, I want you to get to the point. Most importantly, we can see the rigid interfaces make it much more difficult for us to iterate, to change toward a great design like we would in other software projects. This means that we often end up stuck with all design decisions, both good and bad. But that's why you see some softwares or yeah, some softwares that to even update them is a problem because a lot of other services consumes them and a change in one part of it will break a couple of other services, code codes, which is not something that you want. There will be a lot of downtime. So it's very rigid in that case. Generally, we can put more interfaces into two different categories. Those that your users can see and interact with. In software, usually called the front end. And those they can't, usually call the back end. For example, you can easily see the graphical user interface. Yeah, graphical interface is what most and general users will say. Like I'm saying, if you which software, if you go to a site, maybe facebook.com, blah blah blah, or you open their app, what you can see, what you interact with as a normal user is the graphical interface. But as you are clicking, as you're interacting with those interfaces, they are making some calls to the backend that you can see. Do you get it? They are making some calls to the backend that you can't see. So you can't see those things. They are also software, but you can't see those things. So they are tying the backend to the front end. Yes. For example, you can easily see the graphical interface. Ah, wow. You zoom in. However, we don't have the ability to see how Facebook stores social graph and other data. Now, so all those data they have stored about you, what you are posting, the logic, you want to do something and later it's not possible because it happens at the back end. To use more formal terms, we can see that front end, the parts that all users see and interact with, is usually considered public, and back end only visible to a small internal group is considered private. Backend is the server itself, although front end also be server, but the server itself is backend, and that's where most of the things that private should be done. It gives you much more security or secured environment to do things. Okay, because people can actually see it, except they go through your API. So this decision is important because it partly determines our ability to make changes to different kinds of interface, particularly rigid ones like API. Now, I think where this author might lead us to is that if you as a software developer or as an organization, you are in control of both front end, your own front end, and your own back end. Then, if you want to change something in your API interface, you own the two teams. Do you get it? You own the two teams. So when backend want to change something, it is fast. Get it? It's very fast to tell front end and say, a front end guy, change this thing very, very fast. But if it's like a B2B kind of thing, even this B2B, it should be bits to B. One of these B should have S. B's to B. Or B to B. Because if this is you are the business, then you are talking to more than one businesses. Look at if you just change one thing here. Then you have to tell a lot of businesses to change this. And that might not be possible. Because the rate at which your own front end would um would reply or would adjust. You don't expect their own front end to adjust. Maybe their own front end is even on a freelancer or something. Maybe they don't have it in house. So it's not easy to change because you'll be dealing with a lot of front ends. Their own might not even be front end, a lot of other services. That means a server is now connecting to you. It might be server, it might be front end, whatever. So if you make a change to a public service, the whole world will see it and may be affected by it. That's just it. Like B2Bs. Since the audience is so large, you see, carelessly making changes could result in angry. That's just it. While this certainly applies to rigid interfaces like APIs, it also applies to flexible interfaces. Just for example, in the early days of Facebook, most major functional or design changes caused outrage among college students for a few weeks. But what if the interface isn't public? Okay, what if the interface he has done with that part of things now? He's not saying what if the interface is not public? Like I was discussing here, this part of thing. It's not public. If it's within the same team, you still have to inform others and they have to be on the same page with you. They have to be on the same page with you. It also applies to flexible interfaces. Okay. But what if the interface isn't public? Is it a big deal to make changes to back interfaces that are only seen by members of some private internet? In this scenario, people on this same team or in the same office, so it seems we have gained back a bit more freedom. You get it? Possibly even people are on the same thing, like I explained here. It seems we have gained back a bit more freedom. You know, we are free. You can easily tell your guy and say, "Oh, this has changed." This is a great news because it means we would be able to iterate quickly. So why are APIs special? It turns out that when we design many APIs, which are rigid by definition, and share them with the world, we really have a worst case scenario for us because this means that making changes is much more difficult than any combination of these two properties. It's like you are producing something has passed through production. One and you have shipped them. Later on, you are now realizing that you've made a mistake. The mistake is done. Although you can change it, that moving forward, it will be corrected. But before your users adopt or get the updates, you've shipped it. It will take a while. And that could mean angry customers lost investments. So yeah, he's now trying to compare. If it is flexible, then I would have loved this column to come first. Your audience, then flexibility. You get it. If it is private, then it is it might be flexible. Maybe it's an internal monitoring console. If it is public and flexible, what's that? It's public and flexible. That's somehow it is flexible and it is public. There will be advantages. Okay, change difficulty is moderate. It is rigid. It is private and rigid. That way. It is private and rigid. Internal photo storage API. It is rigid and public. Public. Now, public Facebook API is saying that other people are now calling Facebook. It's not only Facebook that is using the API. Other businesses are now using Facebook. So it's B2B. Put simply, this worst of both worlds, this worst of both worlds scenario, both rigid and difficult to change, makes reusable and prove its importance even more important for building API than other types of software. While code is often private and out of sight in most decisions Design decisions in an API are front and center, shown to all of the users of the service. Although your code is not what is not public, but when your code is failing, when your product, your service is failing, then it's going to tell us something about what you have implemented, how your interfaces are. Because you could have a very beautiful interface, user are not able to log in because instead of user email, somebody changed it to email. You see, the API was used to expect user email in the payload of the body, but now it's not expecting just email or email address. You see, although they might mean the same thing, but they're not the same thing to a computer. The computer is not going to take that as the same thing. Now that we have explored some of the reasons these design patterns are important, so design patterns will help us with the rigidity, where it could be rigid, where it could be flexible. I think that's the take home from here. Now let's explore its various components. What makes up a design pattern? I think I'll stop here for now. Need to go to mosque. Thank you so much for getting this far with me. Yeah, thank you so much. All right, see you.